Welcome to Homework Lib.
Hi, so over here we're given an antacid analysis in which we are going to add some hydrogen chloride to the sample and then add sodium hydroxide in order to neutralize the excess of acid added. So over here what we can say is that since the concentrations of HCl and sodium hydroxide are going to have the same value, we can directly do the calculation for the grams employing the volumes. So, in this case, we added 6.73 milliliters of HCl. Out of that, if they didn't react, they would be neutralized by 6.73 milliliters of sodium hydroxide with a 1 molar concentration. Since this is going to be a 1-to-1 reaction in between HCl plus sodium hydroxide to produce water plus the salt, sodium chloride. So that means that the volume neutralized by the antacid would correspond to 6.73 minus 4.91 milliliters, which is 1.82 milliliters of solution neutralized by the antacid. Now, the question asks us what is the mass of HCl in grams that is available to be neutralized? The mass available initially is going to be equal to the volume that we had multiply by the concentration and multiply that value by the molecular weight. So we're going to have 6.73 milliliters of HCl, which is going to have a molar concentration of 1 mole per each liter. We know that 1000 milliliters correspond to 1 liter. And finally, we know that 1 mole of HCl is going to have a molecular weight of 36.46 grams per mole. So the mass of HCl available would be equal to 0.2454 grams of HCl. This is going to be the one available. Now, the mass of HCl neutralized by the antacid would be equal to the volume that the antacid actually neutralized, 1.82 milliliters of HCl multiplied by 1 mole over 1 liter, 1 liter conversion into milliliters, and multiply this by the molecular weight. So in this case, the mass neutralized by the antacid would be equal to 0.06636 grams. And the mass of HCl neutralized by the sodium hydroxide that we added is going to be the same operation, but instead of 1.82, we're going to use the volume that we added. Since the concentrations are going to be the same, the value at the end would correspond. Times 36.46 grams per each mole, which would give us 0.1790902 grams. And with that, it would be all. Over here, we can cut up these values actually to the appropriate number of significant digits to match up. But the answer for the question over here is the first one. I just wanted to add the rest of the solution just for you to be able to understand better the problem. And with that, it would be all. Thank you very much and have a good one.